BTEC level 3, first chemistry one. We'll go through this paper. Ethanol, there's the formula, is a renewable fuel, blah blah blah. It's combusted with oxygen, carbon dioxide and water. So for 1 mark, let me just bring it over so you can see, zoom out a little, 3 marks. For 1 mark, you need to know that oxygen is a diatomic molecule, there's 7, so O2 is one of them. CO2, then carbon dioxide, we should know that, and water, H2O. Then you're going to get 1 mark for balancing this side and 1 mark for balancing that side. So this one was a tricky one. I started off with the carbon because I had 2 this side, and so I needed to stick 2 there. I wasn't worried about the oxygen so much because I can always manipulate those after. And then my second step was to get 6 hydrogens this side. As it works out, by doing that, I'll get 3 oxygens there plus 4 oxygens there is give me 7. I had 1 oxygen standalone there. And just by making that 6, then it was all balanced. So 3 marks for that. Then the question says, if 92 grams of this is reacted, how much carbon dioxide will I get? So how much of this will I get? So I've got 92 grams of this. So I'm going to use this formula, this formula triangle, to calculate the number of moles to see. So once I've got my moles, and then I can plug it back into this side to work out my carbon dioxide. So first of all, I need to know my MR. My MR is just everything added up, remember? So there's 2 carbons. So carbon's the big number of carbon is 12, the mass number. There's 6 hydrogens, and there's 1 oxygen. Comes out to 46. Then I've just covered my finger over moles. Moles equals mass over MR. 92 over 40 gives me 2 moles. So I've got 2 moles here. But I've got, I know it says 2 moles there, but if we imagine a 1 there, so if there is a 1 to 2 ratio, so if I've got 2 moles here, I'm going to have 4 moles here, because this is kind of double the amount of that. The same as if it was this one, if I got 1 mole here, there's going to be 3 moles here, so if I got 2 moles here, there's going to be 6 moles here, because that's the ratio. So you can see there I've brought my 4 moles across. So my MR was 44 for this side, so I just calculated that like I always do. Comes up to 44 now said. So this time mass equals moles times MR by covering my finger over the triangle there. And I've got 176 grams. That was 4 marks. There's another way you can do that. You can actually, if you're worried about the ratio, just when you're calculating your MR by here, instead of 1 times carbon, I do 2 times carbon and 4 times oxygen, because it's 2 times 2 there. And then you don't have to worry about your ratios, and you still come up with the same number because you're doubling in this step rather than this step. In another experiment, it was predicted that 208 grams, but only 136 was made. Percentage yield. So the percentage yield is actual over theoretical. It's going to be the small one over the big one times 100, because you need to come up with a fraction to times it by 100 to make that percentage. So whenever you're worried about percentage yield, just stick the small number over the bigger number, and you're likely to come up with the right answer. Sorry, a bit of a frog in my throat there. So I've said 136 over 208 times 100, 65.4%. I've gone to 1 decimal place there. Probably runs it up. That's fine because it's 2 marks. Sorry, a bit of a technical issue there. Give 2 reasons why the actual recorded mass is lower. This is a standard question, even in GCSE questions. There's 3 big answers. This is worth 2 marks, so any one of these 3 points. Incomplete combustion. For example, if I haven't got enough oxygen, you won't get carbon dioxide, you'll get carbon monoxide, because there's not enough oxygen there. So incomplete combustion, that's all that means, is there's not enough there to combust. The reactants, so the stuff on this side, will react with impurities. So you won't get that full yield, and some reactants get lost during transfer. So if I'm transferring something from a beaker to another beaker, then there still might be stuff on, the inside of the first beaker. So you're not always going to get that maximum yield. Complete the table below. So the second electron shell Well, we know the first electron shell's got 2, and the second's got 8. The third, the 3p, also at this standard, this third electron shell would be 16. So we've got to be careful of that. In GCSE, they teach you 8, but 16 at this level. The 3p subshell. Well, the 3p subshell, the p subshell, there's 3 subshells on the 3p. I know that sounds awkward, but each holding 2 each. So it's going to be 6. So you've got that first subshell. I wonder if I could draw this. So you've got that. So that 1, that's your S subshell, and then your P subshell is like that, and there's 2 each on each of these, going each way. So there's 6. So there's 6 on that one, and then a d orbital. Well, just an orbital. We know an orbital is just a box really, and they can only be a maximum of 2 in each orbital. So even though you think it's going to be 10, because there's 5 orbitals in the d block, only 2 in each orbital. And then a nitrogen atom, well, that's just a small number, because you want to know the number of electrons, and if you want to know the number of electrons, you go with the number of protons, because protons are positive, electrons are negative, and if they're not ion, they're going to be equal to each other. So we've gone for the small number there. Fill in the boxes that represent the electron configuration. So this is oxygen. So you know oxygen's got 8 electrons in total. We're going to start off, this is the Aufbau principle, where we fill the lowest electron energy levels first. So we're always going to start with an up, and then go down, and then up to the next level. So I got another electron, and then go down. And you can imagine this. Remember I had the first circle there. This is your S, okay? And then your second S is going to be sort of, if I draw that, it's going to be your next one around with 2, 1, 2. Maybe I should have done in different colors, but hopefully you get the idea. So I'm going to go up and then down. And then my P will have 3 orbitals. And the way we fill these is 1, 2, 3, and then back to that second one there. So that's how we do that. 4 marks. Easy 4 marks, I think, if I'm honest.